Questions 1 through 10 on the 2002 Grade 8 AMC 8. A circle and two distinct lines are drawn on a sheet of paper. What is the largest possible number of points of intersection of these figures? So you've got a circle, let's say like that, and you've got two lines, one line like here and one like that, right? So that, how many points have we made? 1 point of intersection, 2, 3, and 4, right? Well, let's see if we can do better than 4. It's possible. So let's draw our lines a little bit different. Let's draw them like this. How about like that? Now I hope you can see that we've got 1, 2, 3, 4, and 5. And that's the maximum that we can get. So the answer for number 1 is D. How many different combinations of $5 bills and $2 bills can be used to make a total of $17? Order does not matter in this problem. So you can kind of approach it in any way that you feel comfortable, but the way I did it was how many $5 bills? So either 0, 1, 2, or 3, and so on. But once you get to 4, you'll have $20, right? So that's not good because we only need $17. So we just focus on these combinations. If you have 0 $5 bills, then all of them have to be $2 bills. And can you get 17 with $2 bills? And the answer is no, because this is an even number and that's an odd number. All right? So that's no good. How about if you have one $5 bill? So that means 17 minus 5 is $12. Can you get $12 with $2 bills? Yeah, if you have 6 of them. So that's good. And what about two $5 bills? That's $10. That would leave $7. Can you get $7 with $2 bills? No. For the same reason, right? 7 is odd and 2 is even. How about three $5 bills? That gives $15, and that would leave $1 remaining. $2 remaining, and you can get that with one $2 bill. So these are the scenarios. So it would be one $5 bill, 5 like that, and then 6 of these $2 bills, 2, 2, 2, 2, 2, 2. That would add up to 17. And then the second scenario is $5 bills, 3 of them, and one $2 bill, and that is 17. So there's two combinations, one there and one there. So number 2, the answer is A. What is the smallest possible average of 4 distinct positive even integers? Okay, so smallest. So we'll choose the smallest even integers. The first one is 2, the next one 4, then 6, and then 8. These are the 4 smallest even integers. And we want the average, right? So the average, of course, you divide by 4. And this is, of course, 20 divided by 4, which is 5. And this is the smallest possible average of 4 distinct positive even integers. So 3, the answer is C. The year 2002 is a palindrome, a number that reads the same from left to right as it does from right to left. What is the product of the digits of the next year after 2002 that is a palindrome? Okay, so 2002 is a palindrome. The very next palindrome after that, if you do a little bit of thinking, is 2112. All right, and they want the product of the digits. So these are the digits. The product will be 2 times 1 times 1 times 2. And that is 4. So number 4, the answer is B. Carlos Montado was born on Saturday, November 9, 2002. On what day of the week will Carlos be 706 days old? All right, so make a little calendar for yourself. And he's born here, Saturday. So this is date of birth, D-O-B. And that's the day he was born. And that day, I guess he is 0 days old. So on Sunday, he's 1 day old, then 2 days, 3 days, 4 days, 5, 6, like that, right? So he's 7 days old on the following Saturday. And very similarly, the 14th day will also be a Saturday, the 21st day, and so on, right? So every multiple of 7. So if you go all the way to 706, or as close to 706 as possible, as with multiples of 7, you will be able to get to 706 pretty easily. Well, 700 is a multiple of 7, right? 7 times 100. So the 700th day is also a Saturday. Now let's count from 700. 701, 702, 703, 704, 705, and finally 706. And 706 is a Friday. So number 5, the answer is C. A bird bath is designed to overflow so that it will be self-cleaning. Water flows in at a rate of 20 milliliters per minute and drains at a rate of 18 milliliters per minute. One of these graphs shows the volume of water in the bird bath during the filling time and continuing into the overflow time. Which one is it? So during the filling time, the water is increasing. The volume of water is increasing in this bird bath right here. So which one shows that it's increasing? This one does, and this one does, and this one. This one shows that the volume stays the same, which obviously is wrong because it's filling. The level of water will be increasing. And this also shows that initially the volume is the same, so that's wrong. Okay, now let's move to the second part, which is then you get into this overflow time. What that means is now the water has filled to the brim and now it's overflowing. So if this is your bird bath like that, the water is at that level and that's it. Now it's overflowing off the sides. So the amount of water in the bird bath at this point is going to be the same. Any excess water will just spill over the sides. And that's what is known as the overflow, overflowing on the sides. So since the volume of water during the overflow time is the same, we have to look and see when these graphs show that it is never changing, it's the same. And it looks like it's this one right here. So the answer to number 6 is A. The students in Mrs. Sawyer's class were asked to do a taste test of 5 kinds of candy. Each student chose one kind of candy. A bar graph of their preferences is shown. What percentage of her class chose candy E? Okay, so let's figure out the values here. We got 6, 8, 4, 2, and 5. That's how many, I guess, students chose each of those candies A through E. So the percentage that chose E, well, 5 chose E, and we have to divide by the total. So 6 plus 8 plus 4 plus 2 plus 5, right? So that is 5 over 25, and as a percentage, that is 20%. So number 7, the answer is E. Problems 8, 9, and 10 use the data found in the accompanying paragraph and table. Juan's old stamping grounds. Juan organizes the stamps in his collection by country and by the decade in which they were issued. The prices he paid for them at a stamp shop were Brazil and France 6 cents each, Peru 4 cents each, and Spain 5 cents each. Brazil and Peru are South American countries, and France and Spain are in Europe. Okay, first question. How many of his European stamps were issued in the 80s? So here's the 1980s. And which countries are in Europe? France and Spain. So you add those up, 15 and 9, which is 24. So therefore 8, the answer is D. His South American stamps issued before the 1970s cost him So we're looking at before the 1970s. So we're looking at the 50s and we're looking at the 60s. And the South American countries, which are Brazil and Peru. How much did they cost? Well, how many Brazilian stamps does he have? He has 4 plus 7, which is 11 Brazilian stamps. And each stamp from Brazil cost 6 cents. Correct? Just according to the information they gave me. And then we have to add to that the Peruvian stamps, which are 6 plus 4, so 10 of those. And then how many cents does each cost? Peru is 4 cents, so 4. And let's add this up. So this is 66 plus 40, which is 106 cents, or $1.06. So that would be for number 9B. The average price of his 1970s stamps is closest to. So we're just concentrating on this aspect of the table. So we got 12 from Brazil and each cost 6 cents, plus 12 from France and each cost 6 cents, 6 from Peru and each cost 4 cents, and Spain, we have 13 of them and each cost 5 cents. And we have to divide by the total number. 12 plus 6 plus 13 is 43, I think. So 12 times 6 is 72, 12 times 6 is 72, 6 times 4 is 24, and 13 times 5 is 65, all over 43. So the top is 233 divided by 43, and therefore this is 5.442. So it's closest to, let's see here, E. So number 10 is E.